Welcome to Jonathan Online Physics and Maths. Now, in this class, we have physics task on the board to tackle. Okay, let's look at the question. Of course, the topic is Hooke's law, that is elastic properties of material. We have a graph on the board, and that is Hooke's law's graph. A graph of force against extension. The force in Newton and the extension in meters. Okay, looking at the graph, we have 2, 4, 6, 8, 10 for the first axis, and we have 0.1, 0.2, 0.3, 0, and so to 0.5 on the extension axis. And we can see by the interpretation, it means that 2 Newton force gives extension of 0.1 meter to that elastic material or wire. Okay, and so on. Now we are now asked to why 10 Newton force gives extension of 0.5 meters. Now the question now is, number one, we are asked to use this information to determine the force constant of the elastic wire. Then B, to calculate the maximum elastic potential energy of that elastic wire. Okay, of the elastic wire. Now this is the question. This is the question. Very simple. Let us do justice to this question. Okay. Solution. The first thing we are going to do here is this. In order to find the elastic constant or the force constant of the material, we recall and remember Hooke's law equation. Of course, Hooke's law says that force is directly proportional to what? Extension, provided that the elastic limit is not exceeded. Okay? Now, by this, we have that F is equal to KE, which means K is the what? The elastic constant of the material or the force constant of the wire. Okay, so our question A, we now go to the graph. Let's take a slope. The elastic constant of the material is the slope of that or the gradient of the straight line of the graph of force against extension or load against extension. So let's take my slope from here. I want to take my slope between 2.0 and 10.0. Remember that the gradient of a straight line is constant throughout. So you can conveniently take the slope from here. You can choose to take from between 8 and maybe 8 and 4. You can choose to take between 6 and 2. You can take the slope appropriately from any of the two axes that I'm taking here. So here now is delta F, that is change in F axis. Here is delta E, which means change in extension axis. Okay, to make it simpler, what do I mean? Can I call here, let me call here F1 and call here F2. Let me call here E2 and call here E1 to make it simpler for your understanding. Okay, now the gradient or the slope now, which is given as this, as our constant. So the slope is equal to the elastic constant, because from here, from this place, K is equal to F over E. You see what we mean by the slope? Okay, so which is equal to delta F over delta E. That means the change in force axis over change in extension axis for that graph of Hooke's law gives you the what? The elastic constant or the force constant of the material, otherwise known as the stiffness of the material. Okay, our K now is equal to delta F. We go here changing F, which is our F2 minus our F1 all over, let me write this well, all over delta E, changing E, our E2 minus our E1 from these days, okay, which is equal to our F2 here is 10 minus our F1 here, this is our F1 from my slope, from the places I took my slope points, minus 2 over my E2, this is my E2, from the point I took my slope, this is my E1. So 0.5 minus my E1, 0.1. Then my K now becomes 10 minus 2, of course, is 8 over 0.5 minus 0.1 gives us 0.4. So when you divide this, it's very simple. With our calculator, 8 divided by 0.4 is going to give us 20. How? It simply means 0.4 simply means 4 over 10. That's what it means by fraction. So that simply means when you have this, it means 8 over 4 times 10. That is like saying 8 divided by 4 over 10. I want to teach you how to operate this with a calculator when you are writing exam conditions, aptitude test. So which simply means 8 times 10 over 4. In our mathematical operation, this place will change to multiplication. That this will invert this. And that will give you, this is 1, this is 2. 2 times 10, 20. So our K is 20 Newton per meter. That's the first constant. So the first constant of this material, or elastic constant, is 20 Newton per meter. That's the unit. Newton is for this force. Y meter is for extension. So force over extension simply means Newton over meter. So that language means ratio. Good. Okay. So the B part of the question. The B question asks us to calculate the maximum elastic potential energy of the elastic wire. In other words, we are expected to find the work, the maximum work done by that elastic material extension. Work done by that force for extending that elastic material to the maximum point obeying Hooke's law here in the graph. Okay, so we now talk about the elastic potential. Let me call it elastic potential energy maximum from this graph is equal to work maximum of this force here, which is equal to, now we now have that it will now be equal to the work done, or the last maximum potential energy there, elastic potential energy there, will be equal to 1 over 2 Fe. That's the formula. 1 over 2 Fe. Do you know that this is same thing as the area under the region of the graph? Remember that this area slope gives us a triangle. And the formula for area of a triangle, remember that area of a triangle is equal to 1 over 2 base times what? Height. So when you look at this, the base here is this, which we get. And the height is this. So it is the same thing as saying half of the extension base times the what? The height, which is the what? The force. Okay, so we now have 1 over 2 times the maximum force from here. The maximum force is what? 10, because the question says maximum. So times 10 times the extension, maximum extension here is 0.5 times 0.5. We have 2 divided itself 1, 2 divided 10 is what? 5. Then when you have 5 times 0.5, that will give you 2.5, because 5 times 5 is 25, but this is 0.5, therefore you put 1 decimal place. You have 2.5 joules. Remember, the unit of work done or energy is in joules. Again, alternatively, you can also find the work done here. You can find the work done, the maximum work there, or maximum PE maximum there, to be 1 over 2 K E squared. You can also find it with this formula. If you apply this formula, I'm giving you this as a task. If you apply this formula, you will confirm this answer as well. Try it and drop your answer in the comment section. Remember, K is already 20. If you are using this formula now, K is 20. And our E here, the maximum extension here is what? 0.5. So apply this formula and confirm whether it will still give you this answer. Alternatively, thank you for paying attention to this class. I believe with this, you can tackle any similar question that has to do with Hooke's law graph under elasticity or elastic properties of material. This question is typical for IGSCE, that is Cambridge IGSCE, and as well as SCSCE, that is WAEC, NACO, NABTEB, and UTME, that is JAMB exams. So I want to beg you one thing. If you like what we are doing here, kindly share to all. Just click the share button, then like and drop your comment or question. Then if you need private tutorial, online class through Zoom, Microsoft Teams, Google Meet, if you want private tutorial for preparing for examination, aptitude test, just ring me or chat me via the WhatsApp contact or drop message in my inbox, and I will give you what? Maximum attention and excellent tutorial. Thank you and God bless you. Subscribe to my YouTube channel. Keep following on the Facebook for more updates. Bye-bye.